Welcome back to the International Virtual Conference 2020. I would like to call Dr. Prabhakaran Sir, Head, Department of Physics, to introduce the guest speaker of the session 7, Dr. N. Kanagarada, Madam. Over to Dr. Prabhakaran Sir.
Good afternoon to all. I am very much happy to introduce the last session speaker, Dr. N. Kanagadara ma'am. She has completed her PhD at Presidency College, Chennai, in the field of physics in the year 2000, April 2014, and completed MPhil degree through Bharathidasan University at Sita Lakshmi Ramasamy College, Trichy, and also completed her MSc Physics at Sita Lakshmi Ramasamy College, Trichy through Bharathidasan University, and also completed UG degree in Government Arts College for Women, Kumbakonam. And he has more than 20 years of experience in the field of teaching. At present, working as Associate Professor of Physics at Savitha School of Engineering, Savitha Institute of Medical and Technical Sciences, Chennai, since August 11th, 2017 onwards. And she has published more than 100 research papers in reputed international journals. And her total research citations are 276 and H-index 9, cumulative impact factor 65 and plus. Currently, a recognized supervisor under Savitha School of University and also recognized supervisor for Anna University, and presently guided 5 students, PhD scholars, 5 students, and completed 1 PhD student. That's all from my side. Over to Kanagadara ma'am, please ma'am.
Ma'am, you can start.
Ma'am, Kanagadara ma'am,
Yes,
you can
sir.
start.
Okay, sir. The screen is visible to you?
Yes, ma'am.
Yes, ma'am. Yes.
Okay, good afternoon to one and all. First, I would like to thank the organizers of Anna Willett College of Arts and Science for giving me an opportunity to participate one among you in this international conferences on recent advances in biochemical and medical sciences. And on behalf of Savitha School of Engineering, I am going to present the topic entitled Perspectives of Material Science and its Diverse Applications. That is the various applications of materials. Just I am going to give you just a brief you about what are materials and what are its importance, what are the properties, just the essence of material science. I'm going to brief you. And before start this lecture, let us start this with one quote. Education is about learning to use your mind, not about filling it up with information. This is my outline of my presentation. Introduction, classification of materials and properties, characterization and applications, and some useful links for material characterization. Actually, material science, we cannot claim that only physics people has to do the material research, or chemistry people, or mechanical like that. Material science is an interdisciplinary field involving the properties of matter and its applications of various areas in science, engineering, and technology. It includes elements of applied physics, chemistry, as well as chemical, civil, electrical, and electronics engineering. So the science that investigates the relationship between the structure of materials at the microscale to macroscopic level. So with the significant media attention focused on the nanoscience and nanotechnology, the material science has been propelled to the forefront at many universities. Actually, it combines, as I said earlier, material science combines physics, chemistry, biology, mathematics, and the principles of mechanical, chemical, electrical. As a result, material engineers are highly marketable. See here, maths people can also do the material research. How they can do, say, for example, if you are taking the FTR spectrum, FT, the Fourier transform, the time domain infrared spectrum is converted into frequency domain with the help of the Fourier transform application. So, maths, physics, chemistry, biology, and this is the science subjects and engineering, mechanical, civil, electrical, and put together can contribute their work. So as a result, material engineers are highly marketable. This field is focused on the development of new and better materials for the next generation of engineering applications. So basic engineering materials, we can say metal, ceramics, polymers. And these are all the engineering materials. And non-engineering materials, the advancement of this one, that is the advanced engineering materials, biomaterials, nanomaterials, we can climb. In this new century, sustainability and environmental impact lie at the core of material development and application. Okay, what is material science? Now we have seen. So it is a synthesis, characterization, and properties of material to various areas of science and engineering. So what are the properties we are searching in a material? Normally chemical property, mechanical property, thermal property, electrical property, like that. See, these are the basic things: strength, hardness, flexibility, thermal, magnetic, electrical, stability, all these. So based on the above properties only, we can use a particular material for its suitable application. So just like that, we cannot synthesize one material and we can use it for some other material. Before the application of the material into the relevant field, first we have to test the material. So first thing, structure, we have to identify. So these are all the classes of materials: ionic crystals, covalent materials, metals and alloys, semiconductors, superconductors, polymers, composites, ceramics, inorganic glasses, catalysts, etc. And okay, what is material? It is nothing but whichever is, see, I am wearing cloth, and this mouse is made up of one material, and this cloth is made up of one material, this laptop is made up of one material. So if we look around, everything we see, that is made up of material. So sometimes it is more than one material also. So a material is a physical substance used to make things. Metals, plastics, ceramics, glass are the main categories of the materials. See, for example, if you consider metal, we know metal is a good conductor of electricity and it is very strong one. So that's why we are using for the electrical application. So why the copper is suitable for electrical wiring? What properties must it have? It must have the good conductor of electricity. So that's why it is used. So metals are shiny, strong, and good conductors of electricity. And it is usually opaque, and some metals are magnetic one. Example, aluminium, copper, iron. So like that, we can give some examples for metals. So based on the properties, it has desired applications. See, as a material science student, we may have many questions. Why the glass is brittle? Why the copper is ductile? What is meant by ductile? What is meant by malleable? And why glass is transparent? Why the metal is opaque? Why wire is copper conducting, whereas the wood is non-conducting? How can I change my properties like hardness without changing the composition? So like that, there are so many questions arises. So all these questions simply based on the material properties and its determination. See, this is the material science world. Okay, so when we see the band structure, so based on the band structure, you have metal, semiconductor and insulators. So solids are generally classified into, according to our band theory of solids, we know it is classified into conductors, semiconductors and insulators. Okay, and based on the state, we know gas, solid, liquid, or the state of matter. So solids are classified into amorphous and crystalline. And this is the material zone. So here the based on the band structure, now only we are taking with the band structure and the solid, because what properties determine the structure of the material. So for that, see, let us consider a common description about the engineering materials. Bonding and structure are the key factors in determining the properties of a material. So what properties determine the material? It is nothing but the bonding and the structure. So a common description is given. Okay, so common types of materials are metals, ceramics, and polymers. Okay, and broad scientific and technological segments of material science is given in this diagram. So first, material science and engineering, science of metallurgy. So the properties in the sense physical, mechanical, electrochemical, and technological property. So physical property in the sense generally structure, and mechanical, hardness, strength, ductility, elasticity, yield strength. So like that, deformation, behavior, and corrosion property. And technological, That is the processing, casting, forming, welding, machining, like that. So to gain a comprehensive understanding of material science, the following aspects have to be studied. And generally, the properties of material are determined by the two characteristics. That is, the properties are influenced by electromagnetic structure and atomic structure. Electromagnetic structure, it is nothing but a bonding character of the material. So that is how the electrons or the charges are distributed and spin associated with the electron. So that is a bonding nature of the material. And atomic structure is nothing but how the atoms or ions or molecules arranged in the material, whether it is a regularly arranged or irregularly arranged one. So based on that only we have a classification, crystalline material and amorphous material. So generally properties are influenced. So 2 points we have to differ. One, the properties are influenced by atomic structure. Another one by the electromagnetic structure. See, for example, if you are taking the iron material, normally iron has a BCC structure, but when the temperature is increases at the particular temperature, it changes to FCC structure. At that time, the bonding character simply changes. So the bonding character of the iron material changes. So when the bonding character changes means obviously the properties of the iron also will change. So at the time of BCC, it has one property. At the time of FCC, it has some other property. And generally, there are 4 pillars of material science. See this table: physical structure, electromagnetic structure, kinetics, and thermodynamics. So these are the 4 parameters are very, very important in the material science. And all these parameters are linked by a material.
Kanagadhara ma'am, sorry to interrupt. There is a technical issue, the network issue. You can reshare, you can share your screen and start now, ma'am. From where
Okay,
you
sir.
just now, just now it disconnected.
Okay.
Yes, you can resume the screen share now. You can start screen share again, and you can start your continue with the session.
Now you able to see?
No, ma'am. No, you are supposed to share your screen, ma'am, first. Yes, ma'am. It's getting shared. Yes. You just click that resume slideshow, ma'am. It's gone. Or you just go to the slide which you are in. Yeah. Yes, ma'am. You can continue, ma'am. Thank you, ma'am. Ma'am, please unmute and speak. Please unmute and speak. It will be at the top. Yes. Yes, ma'am.
Now, okay, sir?
Yes, ma'am. You can continue, ma'am. Yes, ma'am. Thank you.
Okay. Actually, there are 4 important parameters that determines the properties of a material. So as a material scientist, we must know 4 parameters. One is the physical structure and electromagnetic structure, kinetics, and the thermodynamics. These 4 parameters that determines the material behavior and the engineered material for its applications. Okay. See, all these parameters are connected together by a bridge, which is called the material characterization. So this only determines the material behavior. And the broad goal of material science and engineering is to understand and engineer this tetrahedron. See the tetrahedron: structure, properties, performance, and processing. And all these are interlinked by characterization. All the 4 parameters, the structure, properties, the performance, and the processing are interlinked one. So the basics of material science involves a structure property relationship. So if you are synthesizing one material and you are thinking that that is suitable for some nonlinear application or some other application, first you have to check whether the synthesized material is the same one, that is a parent combination is present in that. So that is a structure identification. And after that, you have to test the properties. So the basics of material science involves a studying of structure of materials first and relating to to with their properties. So once the material scientists know the property, they can go to study the relative performance of the material in a given application. So first structural identification and the properties. So properties in the sense material characterization, that is mechanical property, electrical property, thermal property, magnetic, optical, or like that. Okay, if it is a transparent to some UV visible region, okay, then we can use it for the optoelectronic application, or it possesses the second harmonic generation property, then we can use it for the nonlinear optical application. So like that, the next one is a property. So once we study about the structure property, if you are well known with the structure property correlation, then we can go on to study the relative performance of the material in a given application. So the major determinants of the structure of a material and thus of its properties are constituting chemical elements and the way in which it has been processed. So further step is the processing. Processing means what? Method of preparing the material. How you are going to prepare that material. Now you have identified the structure and the properties also. Now you are going to how you are going to prepare the material. And next, the performance. That is the material performance for a particular application. So this is a structure property performance relationship. And so properties of a material originate due to internal structure. Electron, proton, neutron. So these affect the properties of a material. So structure changes means what? Entirely the atoms present in the particular material also going to be get changed. So property means behavior or reaction of material against the external stimulus. So structure depends on how it is processed, and a material performance will be a function on its properties. So thus the interrelationship among the processing, structure, properties and performance all are linear. That means interlinked. And this is a broad classification of material science and engineering. Physics and solid physics, crystallography, environmental sciences, chemical engineering and processing, mechanical, electrical, civil engineering, architecture, engineering design, chemistry and biochemistry. So this is the broad classification of material science and engineering. And generally we know this is a major classification of the materials: metal, polymer, ceramics and composites. So under the category we have ferrous ions, ferrous and non-ferrous material, ferrous alloys, aluminium and copper alloys. These are all come under the metal. Metal we have two types, ferrous and non-ferrous. And ceramics, engineering ceramics, barium titanate, piezoelectric and traditional ceramics and polymers and composites. So this is a material tree. And so basic engineering materials and advanced engineering materials. In basic engineering materials only we have metals and non-metals. That is metals, ferrous and non-ferrous materials. Ferrous fully iron based and non-ferrous without iron here. And non-metals you have rubber, plastics, resins. Anyway, it is also a material. So metals. So metals we know they are good conductor of heat and electricity. So here metals are the elements that generally have a good electrical and thermal conductivity property. So many metals have high strength, high stiffness, high ductility. Some metals, iron, cobalt, nickel are magnetic. So these are all nothing but the ferromagnetic material. And the ferromagnetic materials, we know they are all very strong magnetic material, and even it possesses spontaneous magnetization. And at extremely low temperatures, some metals and intermetallic compounds become the superconductors also. Superconductor is what? It is nothing but a complete disappearance of electrical resistivity at a particular temperature. And superconductors has wide applications in skids and magnetic levitated trains. There are so many applications of the conducting materials. And pure metals are elements which comes from a particular area of the periodic table. Examples of pure metals include copper in electrical wires and aluminum in cooking foil and beverage cans, we can say. And metal alloys contain more than one metallic compound. Their properties can be changed by changing the elements present in the alloy. Examples of metal alloys include stainless steel, which is an alloy of iron, nickel and chromium. So the combination of more than one metal and non-metal alloys, that is metal alloys. And so basic engineering materials, here metals property given good thermal and electrical conductivity and relatively high melting point. They are very shiny, that is brightness and ductility, hardness, weldability and strength and castability and toughness. And so this is the classes and properties of the metals. So salient features of the metal. Here the atoms are arranged in a regular repeating structure, which is called a crystalline material, and relatively good strength. They are highly dense and malleable, high plasticity, resistant to fracture, toughness, and excellent conductors of heat and electricity. And it is perfect to visible and shiny appearance, and easily they do not react with easily other elements. Okay, and there are iron oxide. The main drawback of metal is the iron oxide. So corrosion, there is a possibility for the corrosion, occurrence of corrosion in the metals. And metals, ferrous and non-ferrous examples given. So primary elements is iron. Here it contains not containing iron as a primary element. So applications of metals and alloys. So majority of components depending on the iron material, wires or rope, shaft, turbine blade and shaft, gear, and many more applications of metals we can say. And so a few more applications of the metals given in this slide. That is electrical wiring, structure, buildings, structure, buildings and bridges, and automobiles, airplane, trains, and engine components, body, vessel, like that. And the pure metal elements example given: copper, iron, zinc, gold, you can see. And the polymer it is usually based on a carbon-based compound. Carbon as a backbone. Here it is a repeating structure. So polymers are usually very useful because they are very lightweight and corrosion resistant. So metal, they are non-oxide. So easily there is a possibility for the possibility of the metal get corroded. But here corrosion resistant and are easy to process at low temperatures and are generally inexpensive. And some important characteristics of polymers include their softening and melting point and crystallinity and structure. So mechanical properties are generally low strength and high toughness. And polymer are carbon compounds. They chemically consist of carbon, hydrogen, oxygen, nitrogen, and other non-metallic elements. And they have a strong covalent, the existence of strong covalent bond. And this is the characteristics of the polymer. And polymer example given: rubber, fuels, oils, paints. So like that polymer example here. And this is the application of polymeric material, insulated in electrical application as fuels. There are many more applications of polymers and ceramics materials. And classes and properties of polymers. So polymers, so as I said earlier, due to its little, that is lightweight, it is more attractive and inexpensive to make, and usually very easy to process. Either as a sheet we can hold or coatings, like a coating we can do, and more are very resistant to the environment. So there is no corrosion for this. Good elasticity, high plasticity, and most are poor conductors of heat and electricity. So these are all the properties of the polymeric materials. And polymers applications is given here: water resistant coating, biodegradable, and synthetic oil and greases. And ceramics. So ceramics, we are all familiar with the ceramic material. In our day-to-day life, we are using the plates, cup and saucer, and the flower vase, everything. All these are ceramic materials. This ceramic material come under the inorganic non-metallic material. Examples of such materials can be anything from sodium table salt to clay. So ceramics, from sodium chloride to clay, we can give any example. These are simply the oxides of silica. Silicon dioxides. Some of the useful properties of ceramic and glasses include the high melting temperature, low density, high strength, stiffness, hardness, wear resistance, corrosion resistance. And many ceramics are good electrical and thermal insulators. And few ceramics have the magnetic material, that is a magnetic property, and somehow the piezoelectric material, there is a piezoelectric property. So piezoelectric property is what? When a suitable electric field is applied, there will be an that is a production of the electric charge carriers. So piezoelectric property, and piezoelectric materials possess the non-linear optical one, and the ceramic and the glasses have the major drawback: they are very brittle. So what is the main disadvantage of ceramic is it is brittle, so easily it is breakable. And ceramics are compounds of metallic or non-metallic elements such as silicon dioxide, barium titanate, silicon carbide. We can give example for this one. They are all usually oxides, nitrides, carbides, or silicates of various metals. and rock and clay or the natural ceramics. So inorganic, non-metallic solids which used at high temperatures. And so characteristics of ceramics, extremely hard, brittle, poor elasticity, and resistant to high temperature, insulated to the electric current. So insulator, chemically inert, non-transparent, high temperature strength, and the non-crystalline one. And this is the example for the ceramic material: sand, brick, glass, cement, concrete, silicon carbide, tungsten carbide, and application of ceramics. So ladders, insulators of electric lines, and refractory bricks. So like that, these are all some few applications of the ceramic material. And the distinguishing features of ceramics given in this slide is nothing but the properties of that material only. So low resistance, low toughness, as we said earlier. And so it is a high resistance to the environment. So as they are generally essentially metals that have already reacted with the environment, and alumina, that is aluminum oxide, and the silicon. They are all heat resistant material. And applications of ceramic materials. And this is the example given in this. And the major classification of materials with a few pictures here I have shown to you. Metals are good conductors of heat and electricity, and the ceramics and the polymers. The advancement of this engineering material is the biomaterials, semiconductors, and the composites. Biomaterials, normally it has wide applications in the medical field. Biomaterials implantation, some for the nickel titanium alloy and the shape memory alloys, we can use it. Okay, so biomaterials has wide applications in the medical field. And semiconductors, Intel Premium 4, that is a computer we are using system. Electrical properties between the here the semiconductors, the properties lies in between the conductors and the semiconductors, and the electrical properties here can be precisely controlled. And the composites, it is more than one material. It is a combination of one or more material. And so this is advanced engineering material picture given. And here in Mendeleev periodic table where it presents, that is highlighted in the yellow color. And so composites, so reinforced cement, concrete, and vinyl coated steel, fiberglass. So combination of one or more material, that is the composites material. So and if two materials are joined together, that is two material, combination of two will give the better result. So composites have the better results. So ultimately high strength, stiffness, and corrosion resistance. And the semiconductor, so semiconductor is the, we know, electrical conductivity lies in between the conductors and the insulators. So common examples for the semiconducting material, silicon and germanium. So these are all the examples for the silicon and germanium. Here, the recombination of the charge carriers at this material will give you the current, whereas some specially fabricated semiconductors, that is the compound semiconductors, it is a combination of two group elements. Second and fourth and the third and fifth, like that. The combination of two group elements will give you light radiation. That is the recombination of charge carriers at the junction results in the light radiation. This emission of light radiation will be useful in the many field. That is say for example lasers, semiconductor laser. So semiconductor laser, what they are using, they are joining a p-type semiconductor together with the n-type semiconductor, and DC voltage is given, and that p-type and the n-type semiconductor material are made up of the gallium arsenide phosphide, like that. So maybe a homojunction semiconductor laser or a heterojunction semiconductor laser. So combination of that is two group elements is the compound semiconductor. Such type of semiconductors, when your forward bias is connected to that, then it will result in the light radiation. So the emission of light radiation in some specially fabricated semiconductor diode is called the semiconductor laser. That is a basic principle that semiconductor laser is used in for various applications. Here, with the help of laser, that is fiber optic endoscope. So like that, there are so many applications with the help of that one. And example for semiconducting material. So we are examples of semiconducting material: gallium phosphide, gallium aluminum phosphide, gallium indium phosphide. So like that. And application: photon cell, light emitting diode, transistor, diode, and amplifier. So here in the transistor, in this case, we have only the no, that is silicon and germanium material. The light emitting diode, in that case only we are using the gallium arsenide like that, and mainly laser and biomaterials. Biomaterials are structural application in the medical field. So material which are used for structural application in the medical field is the biomaterial. And biomaterials have the biocompatibility. See, it is a medical application, means the whatever be the material, biocompatibility, that is eco-friendly, is very, very, very important. Otherwise, we cannot use the material for the particular application. You are synthesizing one material. Say, for example, if you take a nickel titanium alloy, that can be used for the hip replacement or some other thing we are saying, or microsurgical instrument, we are using some biomaterial. Just like that, we cannot use it, even though it has the property, it satisfies the criteria for that. It must have the biocompatibility. Biocompatibility means it should not affect the system. Okay, and so here the biomaterials should not produce any toxic effect in the body tissue, because our body tissues are very, very sensitive. So biocompatibility as well as eco-friendly is very, very important while you are introduced particular material in the market. So use as component to be implemented in the human or animal body for replacement of damaged or diseased part. See, for example, in teeth, suppose if you are having any problem, then maybe there will be the dentist will keep some wires, that is a nickel titanium wire, the teeth, and orthopedic and dental arc wires, microsurgical instrument, and a blood clot filter. And these are all the applications of the biomaterials. And see, structure. See, structure property relationship I told you. And how the structure start? Microscopic to macroscopic level. So subatomic level to bulk level. Subatomic level less than 0.2 nanometer, and atomic 0.2 to 10 nanometer. Microscopic 1 to 1000 micrometer, and bulk greater than 1 millimeter. See, subatomic level metallic bonds. So 1, 2, or 3 valence electron. Valence electron is nothing but an electron present in the last orbit. Those electrons are responsible for the electrical conduction, because these electrons are loosely attached to the nucleus. So once the energy is applied, even with a small amount of energy is applied to that, the electron tend to come out from that nucleus, and once it left out from the nucleus, it is said to be the free electron, and that is responsible for the electrical conduction. So we can find this in the metallic bond. And so the properties, in a sense, so normally once the electron flow, it means what? Current is there. So good conductors of electricity and heat. So electron flow is nothing but the current, and metals have the luster appearance, that is shiny, and it is susceptible to corrosion, which is the disadvantage of the metal. And they are strong but deformable. So there is no deformation is impossible in this. And ceramics and glasses. Ceramics and glasses, ionic bond we have. That is here. Metals, ceramics, and polymers, I told you that is a classification of materials. And what type of bond exists in there? Ionic bond in ceramics and glasses. Whereas in polymers, covalent bond. In metals, we have metallic bond. Okay, so that's why I told you in the first slide itself, bonding and structure determines the properties of a material. That is, the properties are highly influenced by the bonding as well as structure. Okay, and so ceramics and glasses, they are thermally and electrically insulating and resistant to high temperature, and they are very hard and but brittle. And polymers, so polymers we have covalent bond. That is, the covalent bond sharing of electron between the two atoms. And here they are very large molecules, low density, lightweight materials, and extremely flexible. And atomic arrangement, ordered and disordered. So ordered, we know that is the atomic level, 0.2 to 10 nanometer. And crystalline materials, we know here the atoms and molecules are arranged in a regular pattern. So if the crystalline material get break, the broken pieces also exhibit the property of crystalline. That is, in the broken pieces also there will be an stacking of arrangement. That is the regular arrangement of atoms and molecules. So stacking can affect the properties. That is the ductility. Anisotropic, that is a directional. There is no direction dependent. So that's why in the crystallography we are taking any axis as x-axis, y-axis, and z-axis. And in non-crystalline materials, there is an amorphous material. Atoms only have a short range. They are here, the atoms and molecules arranged in irregular pattern. So here, viscous material, generally complex formulas are rapid cooling. These are isotropic materials. So with respect to the direction, there will be a changes in that. So the direction dependent and direction independent. And single crystal, polycrystalline, for that examples given. So single crystal, periodic arrangement of atoms. It is very difficult to grow. And anisotropic materials. But in the polycrystalline, we cannot expect the material may be only the anisotropic, maybe a chance for the isotropic. Here, several crystals may initiate it and grow towards each other. So this is the polycrystalline one. And in the bulk one, greater than nanometer, 1 millimeter, we have the mechanical property, optical, and electrical, and thermal. And material characterization. See, next we come to material characterization. So property we know. Next we have to do what? We have to characterization. So atomic level, from microscopic to macroscopic level, we have to characterize the material. So material characterization has two main aspects: accurately measuring the physical and the chemical properties of a material, and accurately measuring the structure of a material from micro to macro level, atomic level to microscopic level. A critical part of material science and engineering is to study the relationship between the properties, structure, processing, and performance. So first, property, structure, and processing used to make the materials, what kind of method you are going to adopt, and ultimately the next one is ultimate performance of the material in the given application. And the materials and the properties. So these are all the common properties, list of properties. Here is a list of properties which describe the different materials: shiny, strong, flexible, based on weight, and color, and magnetic, transparent, and malleable, brittle, hard, conductor, insulator. So these are all the general properties, some list of properties given here. And this is a classification of the material property: mechanical, thermal, optical, electrical, technological, chemical, magnetic, and physical. See, usually crystal growth people, we will go for the structural part. That is single crystal XRD, powder XRD. Then for structural identification, we will go to FTR and FT-Raman. And further we can go the properties, in the sense of dielectric property we will do. And mechanical, in mechanical only we will take hardness. But the mechanical guys, what they will do is that they will go for the elastic strength. So the entire complete information about the mechanical strength of the material they will do. And the thermal chemistry people, normally they will adopt this thermal technique, DSC, differential scanning, calorimetry, and thermal decomposition, kinetics. So separator, they will do this as a one part. But normally crystal growth people, they will find out only that how, what is the thermal stability of the material. That is up to which temperature the material can tolerate. So like that, the thermal stability and hardness, what is the strength of the, whether it is a soft magnetic material according to the Mayer's index, it is a soft material or a hard material. So like that we used to tell. And in optical, we used to say about the transparency in the UV visible region. That is, we will go for UV visible characterization, and we will find out the transparency in the UV visible region. And based on that, by using the Tokos plot, we will find the band gap. So based on the band gap value, we will say whether it can be used for a semiconductor material or wide band gap. So like that, something we will do. And the electrical, we will normally we will use dielectric characterization. How the dielectric constant and the dielectric loss will vary, and the chemical property and a magnetic property. So magnetic property, suppose if in your material, if a magnetic specimen is there, then we have to go for the magnetic test. Okay, and physical test. So normally these are all the material property and important properties of materials: mechanical property, electrical property, dielectric property, magnetic property, optical, corrosion, and biological. And this slide, see the slide, this will give you the electrical, in electrical property we have electrical conductivity and resistivity. Dielectric properties, we have polarizability, capacitance, ferroelectric properties, piezoelectric, pyroelectric. So only with the help of the dielectric study, in one paper I found that the broadband dielectric spectroscopic analysis of one nonlinear optical material. So that is only by using the cold plot they used. So but normally we used to find out the dielectric constant and the dielectric loss, how it varies with respect to the frequency. And a magnetic property, suppose if a magnetism is a inward material, then it is a magnetic property. You have to go for the VSM, vibrational sample magnetometric test. And mechanical property, elasticity and stiffness, ductility, strength, hardness, brittleness, toughness, fatigue, and creep resistance. And optical properties, refractive index, absorption, reflection, transmission, birefringence, like this. And corrosion property and biological property. Antimicrobial test also some people are doing for crystal materials. And material testing. So testing of the metals is very, very important, and which is a narrow field than the material science and engineering. It determines the strength of certain materials. So commonly safety, and it is not used to design new materials to be used in new applications. So suppose if you are going a new material, just like that, we can't use it for the new application. It should be tested first. So the engineering of fantastic new materials is not a given, but a natural outgrowth. So it is here that science and engineering almost both are interlinked. That is, there should be a touch with both engineering and the science. So from starting to the Stone Age, Copper Age, Bronze Age, and Iron Age, now you are in nano world. So as our knowledge of material grows, so does the sophistication of our tools also increases. So once the sophistication of our tools increases, more the sophistication, the more will be our accomplishments. And material characterization is what is nothing but process of measuring and determining the physical, chemical, mechanical, and the microstructural properties of a material. So generally, material characterization has two main aspects. One is to measuring the physical and the chemical properties of a material, and another one is used to find out determine the structure of a material. And next step is the mechanical and electrical magnetic property or strongly depend on the structural characteristic. Suppose if the structure BCC to FCC changes, obviously this entire property, mechanical, electrical, magnetic, all will entirely change. So therefore material characterization is very, very, very important part in the structural property correlation. And so when you go for material characterization, generally there are image analysis, surface analysis, structural, organic, and elemental analysis. So this is the innovation diagram for the material characterization technique. That is the test you are going to adopt. Suppose I am taking some non-linear optical material. Say for example, suppose if you consider one optoelectronics department, their focus only in the optical property and the electrical property. For them, there is no need of doing for some other antimicrobial like that. They are going to use it for some other application in the electrical side or electronic side. Means for them, there is no use to test the antimicrobial test or some other test. Just for example, I am giving you. So the test what you are going to characterize it must be unique, and you have a deep insight into that problem. That is, you are choosing one problem, you must have a particular knowledge in that. And it must be unique. And what is the advanced you are using? First atomic absorption spectroscopy. Before that, normally we used to take for the presence of the metals. Nowadays, EDAX they are using. Okay, so based on that advanced technique you have to choose, and before that cost, complexity, and thorough knowledge about that material, everything is important. So this is the innovation for the characterization technique. And in the left side you have the analysis: image, surface, structural, organic, and elemental analysis. In imagery, you have the optical microscopy, confocal microscopy, and STEM, TEM, all these are all come on the image analysis. Surface analysis, you have electron spectroscopy, X-ray photoelectron spectroscopy, and low energy electron diffraction like that. And structural analysis, XRD, Raman, TEM. So that also you can use it. So Raman spectroscopy not only for the structural identification, it is also used in the functional group present in that material. That is those peaks which are all inactive IR, that is infrared, that can be mainly seen in the Raman spectrum. Okay, so those bands which are all weak in the IR, it can be seen in the Raman spectroscopy. So for structural identification as well as in the functional group presence, you can go for the FT Raman. And organic analysis, you have the Fourier transform infrared spectroscopy, Fourier transform Raman spectroscopy, and the gas chromatography. The gas chromatography, high performance liquid chromatography, normally chemistry people and biochemistry, I think so, they will use. And elemental analysis, that is the presence of the carbon, hydrogen, and nitrogen in that material. That is the CHN analysis, the elemental compound presence in that material. And optical atomic spectroscopy, inductively coupled plasma, EDAX, we can use it. And the industry side, like semiconductor application, magnetic storage, biomedical, and thin films, chemical plastics. And so these are all industries served. And see, these are the useful links. And I request the organizer to share the link to the participants so that they can use it. Actually, this link for the beginners, those who are just doing their research, only started their research, or the MSc students, this slide will help you. So organizers, please share the slide to the participant, how to plot FTR graph and how to find the crystallite size. See, D by Sharir formula, we will find the crystalline size of the given material, and how to and Hall plot, and how to create the baseline correction like that, and how to from the some softwares are given, and how to extract the data and extract the plot in origin and the slope the line, so like that. Okay, so crystal phase identification. So these are all there are 12 links given. It is freely available in the internet. You can use it. So this slide will help for the beginners. And see, information needed about the structure and the composition. So microscopic level to microscopic, nanoscopic level now. And this is a metal composition and structure. Elemental, we have XPS. And see, future development of societies, significance of material science for the future development of societies. See, continuous day by day materials, researchers are finding new materials for interesting applications. So continuous improvement and the development of existing material and a technological process which ensures the environmental protection and improves the conditions and extending of human life. The fundamental aim of material science and engineering is a material selection. See, for example, even you take the case of COVID-19. So day by day, they are telling new vaccine. So biochemistry people, they are inventing new, okay, biomedical field. So they are achieving something, 90% achieve target, we achieved 75% Sputnik, Covaxin. So like that, day by day, they are inventing new things. So the existing thing of, actually the development of the existing material. So the fundamental aim of material science and engineering is a material selection. And so first you have to select the material. And directions of activities of material science and engineering ensures the achievements of strategic aims of the developments of societies, including material design, computational material science, advanced analytical method, manufacturing, processing, nano, smart material, and biomaterial like that included. So computational material science, actually my work is related with the computational, and I am doing in density functional theory. That is a theoretical work of the material with the help of the Gaussian software tool. So theoretical prediction of the will give you the deeper understanding about the property of the material. See, for FTR, actually theoretical as well as experimental we will do. So mostly first we will, with the help of the crystallographic information file, we will run with the Gaussian software. And first we will identify the properties of the material, optical property, and that is thermodynamic parameters we will calculate, and the FTR, FT Roman, and the structural. And later on we will go and we will compare the geometrical parameters, structural with the experimental one. And if both the results, and we will give the comparison results to that. So computational material science, without investing more into the material, first we will predict the material property. And once we are satisfied with the theoretical results, then we will move on to experimental one. So depend upon the facility available we have, we can go it. And we should not always, we should have a confidence. Even in some colleges, we don't have facility at all. At the time, we should not claim that we don't have any facility. We will not do anything like that. Whatever be the facility you have, that you can write. Even if you want to publish a paper, no need of any equipment or other thing. Even if a Gaussian software you don't have, I have a Gaussian software, I am working on it. That is my work. Okay. Suppose if you don't have anything, don't need to worry about it. You just go through all the papers. If you are choosing one material, say for example, whether it is a KDP or ADP or triglycine crystal, whatever it is, you take as a or MSc student or a beginner of research work, what you can do. If your guide is giving you some topic, you just go through the topic well. Based on that, you start to write a literature survey. Literature survey alone will give you the best paper. So with a small facility you have, you just use it. Okay. And material science and engineering links many different disciplines. So it's simply a bridge between the designers who use materials and scientists, and who devise and develop the new ones. It deals with the physical stuff of which everything is made, and thus connect the engineering and the scientific concepts with the real world of products and people. It is critical to our survival in an increasingly technology and a material dependent world. And material design and selection. So first you have to design for a given application. First, you have to determine for what application you are going to do, which material you are going to select. So design as well as selection is very, very important in choosing a material. And so a good material scientist will consider these points. First, the effect of how the material is made. What exactly is the composition of the candidate material for the application being considered? And the processing have to be done for shaping the material of fabricating a component, the structure of the material after processing onto a component device, and the environment in which the material will be used, and the cost to performance ratio. You are giving the course level one project like your guide got or you are doing, and your project is worthy for that. So that's what you have to make your project. So cost to performance ratio. And at last, I would like to conclude in conclusion of my topic. And the goal of material science and engineering is to design materials with certain properties which gives a certain desired performance. So using suitable processing techniques, the material can be synthesized and processed. So the processing determines the microstructure of the material. So the material is expected to be used in the structure. To understand the microstructure of the material, scientists has to traverse across the length scale, that is micro scale to macro scale. The residual stress state in the material is also very, very important. And common types of materials, that simply I'm summarizing the topic, what we are seeing now, metal, ceramics and polymers. And the hybrid one is the composites. And the materials are also classified based on the band structure, metals, semiconductors and insulators, and atomic structure level, crystals and amorphous. And in conclusion, there are many unique properties and further investigation of, so there are so many materials now, the research is a wide one. There are new materials yet to discover. So further investigation of toxicity is needed. There are many ways to synthesis, and the method of synthesis depends on financial needs and amount of product desired. If nothing is in our hand, simply one beaker, one magnetic stirrer enough to get the material. So there are many exciting applications of the materials. The knowledge of principles of material science and engineering will empower you with the fundamental concepts. So this will allow you to make technically sound decisions in designing with the engineering materials. And so today's nanos you see. And to remember for comparison, this chart will give you, that is lengthwise the scale is given, and to some carbon nanotube. And so these are all the applications. And this is all the materials. And I would like to conclude my talk. On behalf of the organizers, I wish for your future to be a successful one. So first, I would like to thank my parent institution, Savita School of Engineering, for encouraging me, always encourage me to do my work and research work. They motivate me. And my host institution, Anna Violet College of Arts and Science, Ambattur. And I would like to thank the founder and chairman of Anna Violet College of Arts and Science, Professor Dinabalan sir, and the patrons Prem Kumar sir, secretary, and joint secretary Premchand sir, and the principal Dr. Mrs. Kamala Balakrishnan madam, and vice principal Mrs. Jeffia Solomon, and the convener Dr. Department of Chemistry for the opportunity given to me to participate one among you. And I would like to thank my friend as well as the co-convener of the conference, Dr. M. Prabhakaran sir and Chandramohan sir, head of the Department of Physics, Dr. Prabhakaran, and head of the Department of Biochemistry, Dr. Chandramohan sir, and who made me to present in front of you. Standing here because of them. Thank you so much, Prabhakaran sir and Chandramohan sir. And my area of research interest is crystal growth, spectroscopy, density function theory, and thermal decomposition kinetics. And this is my email ID and WhatsApp number. Participants, if you want, you can contact me at this number and the mail ID. And thanks for listening. Academics as a young dynamic personality, Sundar Pichai said, academics is important, but not everything. Take risks, try different things, follow your passion. Thank you. Sir. Parimala madam.
Thank you, madam.
Question answer, ma'am. Some questions have been asked.
Ma'am, please talk louder, madam.
Thank you for my presentation, particularly in the field of material and material science.
So 1 second, sir. So 1 second, please. I will switch off the fan. Fan switch off. Please tell me, sir.
We have received some questions in the chat box. The
Okay.
question is, how will you identify the zone crystal belongs to centrosymmetric and non-centrosymmetric crystals?
Centrosymmetric crystals, actually, we have 252 space groups, sir. And there will be a center of inversion in that. See, for example, if you consider the triclinic material, it is a pre-inverse. So inversion, center of inversion is present in that material, then it will be the non-centrosymmetric crystals. So there will be symmetries, what left, right will be the same one. So from the single crystal XRD, you will be getting a structural parameters. They will give you the space group. So from the space group, you can identify based on the center of inversion.
Okay, no problem. Next question is, what is the relation between nano computing and quantum computing at the aspects of material science analysis?
Nano computing, and actually nano is not my part. And so quantum level they are using.
Okay.
So nano 200 nanometer miniaturization of this.
Okay. Third one is, how to combine material science with robotics? No?
Material science, yeah, obviously. In robotics also, mechanical engineers they are doing. No, actually, my work is related with only the computational material science. But robotics also, they are using so many engineering components. Engineering components are obviously related with materials only. So there may be some technique in that. In robotics, there will be a flexibility in the material. So flexibility test like that.
Okay, ma'am. Thanks for answering all the questions. Now over to Mr. Vikram.
Thank you, sir. Thank you.
Thank you, sir. I would like to call Dr. A. Chandramohan sir, Head, Department of Biochemistry, to announce the prize winners of e-poster presentation. Over to Dr. Chandramohan sir.
Thank you. Thank you for the wonderful session, madam. I'm Dr. Chandra
Thank you, sir.
Mohan.
Thank you.
At the end of the session, we came to announce the results and we got the results. Actually, I congratulate all the participants who has presented the poster. All the posters has been very best. It's a very tough task for the judge to judge this. Actually, to judge from internal and external, and the results has been given. The best poster award goes to Sureka Ramachandran, SRM Dental College. The best poster awards. The third prize goes to Rimjim Patak from Dayal Bagh Educational Institute, Agra. Then the second prize goes to Niraj S. Tropar, MIT World Peace University, Pune, School of Chemical Engineering, MIT World Peace University, Pune. And the first prize goes to Dhanajay K. Durv, NV Patel College of Pune and Applied Science. Thank you. Thank you for all the participants. Over to Vikram.
Thank you, sir. I would like to call Mrs. S. Jabashija ma'am, Assistant Professor, Department of Biochemistry, to deliver the consolidated report of this International Virtual Conference 2020. Over to Jabba ma'am.
Thank you, Vikraman. Good evening to one and all. I take this opportunity to consolidate the report for the 2 days International Virtual Conference. IQAC and the Department of Biochemistry, Chemistry and Physics of Anna Violet Arts and Science College organized an international conference on the topic Recent Advances in Biochemical and Material Sciences 2020 on 25th and 25th November 2020. The conference was started with a prayer song by the college choir. College Principal Dr. Kamala Balakrishnan welcomed the gathering. Dr. L. Parimala, Head Department of Chemistry, briefed about the conference and the department. Session 1 was started at 9 a.m. and was presented by Ms. Devika Krishnan, Research Associate, University of Connecticut, US, on the topic Nanotechnology in Biomedical Research. She explained about the techniques and the applications of nanoparticles in different fields. Session 2 was started at 10:30 a.m. and was presented by the guest speaker, Dr. Prem Saran Thirumalai, Assistant Professor, Department of Botany, Dayal Educational Institute, Uttar Pradesh, on the topic Transcriptomics for Understanding Life Functions. He briefed about the applications of transcriptomics for understanding life functions. Session 3 of the International Conference was started at 1 p.m. The guest speaker, Dr. Tyagarajan Sandhanamari, Assistant Professor and Coordinator, Department of Microbiology and Immunology, Faculty of Applied Medical Sciences, Northern Border University, Kingdom of Saudi Arabia, gave a lecture on the topic An Insight into Pathogenesis of Helicobacter pylori-Induced Autoimmune Thyroiditis. He gave a brief note on the prevalence and significance of autoimmune thyroiditis. The last session of day 1 was started at 4 p.m. and was presented by Dr. Pachamuthu Kandasamy, Senior Director, Head of Medicinal Chemistry, Wave Life Sciences, Cambridge, US, on the topic Oligonucleotide Therapeutics. He briefed about the oligonucleotide targeted drug delivery, chemical modification, mechanism of action, and the therapeutic uses of different types of oligonucleotides. With these 4 sessions, the first day of the international conference entered successfully. On 25/11/2020, day 2 of the international conference was started at 10 a.m. with a prayer song by our college choir. Session 5 was enlightened by Mr. Velmurugan N. Ramachandra, Vice President, Engineering R&D, USA, on the topic Digital Advancements in Biomedical Devices. He explained about the advanced devices used in the field of biomedical research. Session 6 was presented by Dr. Ananda Kumar Pandi, Assistant Professor, Department of Biochemistry, All India Institute of Medical Science jargon at 11:30 a.m. on the topic carcinogens, the key role players in cancer. He explained about the causes, symptoms, and prevention of cancer. Session 7 started at 2 p.m. and was presented by Dr. Kanagadara, Associate Professor of Physics, Savitha School of Engineering, Chennai, on the topic Perspectives of Material Science and its Diverse Applications. She briefed about the applications of material science in various biomedical fields. Feedback was received from all the participants in all the sessions to upgrade the standard of the forthcoming events. All the sessions were highly informative and interactive. At the end of the virtual conference, the aim of the conference was fulfilled, and we hope that the participants receive intelligent insights from all the guest speakers who all are the leading professionals. Surely, it could be a stimulating factor for personal as well as professional growth for the students and young researchers. In addition to the guest lectures, we received 64 e-posters from various institutions all over the world. All the posters were acknowledged and selected posters were allowed to present through the Zoom platform, and the best posters were honored. We are happy to share with you all that we have crossed nearly 5,000 views in 2 days on air through YouTube. Hence, we conclude that the International Virtual Conference on Recent Advances in Biochemical and Material Sciences 2020 was a grand success. Thank you, one and all.
Good evening, sir. Prabhakaran sir.
I'm ready.
Prabhakaran sir will propose vote of thanks.
Good evening.
Prabhakaran sir,
Yes, ma'am.
can't able to hear, sir.
Prabhakaran sir, place your mic near to your sir. The voice is very low.
Audible? Hello.
Yes, sir, but the voice is still low. Please be louder, sir.
Okay. Good evening, all. On behalf of Unavailed Arts and Science College, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this international virtual conferences on recent advances in biochemical and material sciences 2020, organized by Department of Physics, Chemistry, and Biochemistry. First, we have to thank the Almighty for His every rays of glory showered upon us at our every step taken with regard to the successful completion of this 2 days international virtual conference. At the outset, I thank our guest speaker and resource persons of 2 days conference. First, Mrs. Devika Krishnan, Dr. Prem Charan Thirumalai, Dr. Tyagarajan Sandanamari, Dr. Pachamuthu Kandaswamy, Mr. Vel Murugan and Ramachandra, Dr. Anandakumar Pandi, and Dr. N. Kanagadara. We are really enlightened with your knowledge and presence, sir. We are thankful to our honorable founder and chairman Chevalier Dr. N.R.D. Tanabalan and Secretary N.R.D. Prem Kumar and Joint Secretary Dr. P.R. Premchand for their motivation and encouragement. I would like to thank our principal Dr. Kamala Balakrishnan and the Vice Principal Mrs. Yapia Salaman for their enthusiastic support. A special thanks to the convener Dr. L. Parimala, HOD Chemistry, and the co-conveners Dr. Chandramohan, HOD Biochemistry, and Dr. M. Prabhakaran, HOD Physics. I take this concurrence to thank the entire conference committee members from Biochemistry Department, Chemistry Department, and Physics Department faculties, Mrs. Jabasija, Mrs. Meena, Dr. Rohini, Dr. Karini, Dr. Ramya, Dr. Rita, and Dr. Daini Lakshmi, and the students, Kamper, Mrs. Bharati, and Mr. Vikram, as well as the audience for presenting their valuable views. Our grateful thanks to the technical team members, Mr. Yuvanis, HOD of BBA Department, and Mr. Vinod, Assistant Professor, Computer Science Department, for their systematic and befitting arrangement in amalgamating both audio and video, which is vital in all walks. Our special thanks to teaching and non-teaching
staff members for their unfailing support and coordination. Our heartfelt thanks to our students for active participation, and all over the world we have received several viewers from participants. With these warm words, with warm words and a kind message, we move to the end of the today's